Hello dear students, today I will discuss the remaining questions of miscellaneous exercise of chapter probability. Okay, probability chapter is very important, but only this year binomial distribution and mean variance of random variable are not in the syllabus, so accept those questions. Just I am continuing remaining all formulas for solving questions. Okay, so just in this chapter, our main formula was what? Conditional probability. Conditional probability means just we are using like formula PA by B. What? P A intersection B by P B. Conditional probability. Conditional probability. Just P B by A. Also, you can write P B by A means what? P B intersection A upon P A. Here P A and P B not equals to 0. Very important, because two events, just when we are setting up two events, A events, B events. These events, just below events, the second event, it already happened, and then what is the probability of happening the event A? Here, A already happened, and what is the probability of event B? When they are, if they are independent, then just we can write PA into PB. Okay, conditional probability. So here BA, because this is equals to PB intersection A, PB into PA for independent events. And Bayes theorem, just we know Bayes theorem, what? EI upon A equals to what? PEI upon A upon sum of j equals to 1 to n P EJ into PA by EJ. This is Bayes theorem. Used for what? Bayes theorem is used for finding reverse probability. Here, just total probability. From the total probability theorem, just we write total probability in the denominator, and in the numerator, PE into, PA by EI. I equals to 1 to up to n. This. Okay. EI by A equals to this. So from here we can find the reverse probability. Just some events are happened before, and then for depending on that the event is happening, and what is the probability of that event if the previous event was like this. That is reverse probability in find by using Bayes theorems. Sometimes you can use also conditional probability theorem, conditional probability formula. Okay. For independent events, just we know PA intersection B equals to PA into PB. This PA intersection B is equals to what? PA into PB for independent events. Okay, independent events. Independent events. Just you can see here. From here, PA intersection is equal to PB into this, PB intersection is equal to PA into this. And if conditional, if independent image, then condition is having no effect. So PB by A equals to also PB. PA by B equals to also PA. So PA into PB, PB into PA. PA intersection is equal to PB, independent image. So these are the basic formula for solving the questions of this chapter. Okay. So also basic thing you have to understand. First, by studying the chapter very deeply, then you can solve questions from yourself. Okay. So here, question 14. Just see here, question 14. What is question 14? If each element of a second order determinant is either 0 or 1, second order determinant, just we know, second order determinant, 1, 2, 3, 4 elements are there for a determinant, second order determinant. Each element of second order determinant is either 0 or 1. That is, 4 places will be filled by 0 or 1 in any of the combination. Okay. So what is the probability that the value of the determinant is positive? Assume that the individual entries of the determinant are chosen independently, each value being assumed with probability half. Oh, very clear. Okay. Because two elements are there, so independently we can choose any of the values, either 0 or 1 for 4 places. So what is the probability that the value of the determinant is positive? So just we see here solution 40. Total number of second order determinants total number of second order determinants with each element being either 0 or 1, either 0 or 1. Okay, is what? 4 places, because we know determinant like this 1 0 0 1 or 0 1 1 1 or what 1 1 1 1 or just 4 places are filled with 0 1. So 4 places are filled with two different objects, 4 places. So what is the total number? 2 to the power 4 is 2 to the power 4. Just we know from the chapter of combination permutation. Okay, 4 places can be filled with two different objects just in the 2 to the power 4 ways. So this is equals to what? 16. Okay. Now total number of second order determinant. Positive determinant. Value of determinant will be positive. When? Value of determinant will be positive. Just we can see that here. 1, just this side are subtracted. This side are subtracted. Okay, 1, 1, 1, 0. Or 1, 0, 0, 1 or what? 1 1 1 0. These three are possible ways. Okay, so 1 minus 0 1, 1 minus 0 1 minus 0, 3 ways. Just other combination you can see. Also, what? 1 1 minus 0, not 0. Second order determinant, 0 is not taken as a positive or negative. Okay, so accept 0 na? Here. So how many possibilities are there? Like this. The value of determinant, the value of determinants is positive in following cases. As 1 0 1 1, 1 0 1 1. And how can we write other way? 1 1 0 1 1 0 and also here 1 1 0 0. Just you can see accept integral, just matrix. Okay, this. Okay, so total combination may be what? 16. So this three determinants gives positive value. So the required probability, then the required probability is equals to what? Favorable cases 3, total cases 16. So this is probability 3 by 16. Okay, so this is the answer. Just you have to decide how can you find the probability of a particular questions. Okay, so here question 15. Question 15. An electronic assembly consists of two subsystems, say A and B. That is, an electronics assembly consists of two subsystems. Means assembly is organized, and here there are two subsystems, system A and B. From previous testing procedure, the following probabilities are assumed to be known. PA fails, just given PA fails 0.2, means system A fails, probability of that 0.2. System B fails alone, not both fail. System maybe both fails. System B fails alone 0.15. System AB fails, means both fails 0.50. Evaluate the following probabilities. PA fails by B has failed. It is conditional probability. PA by B. In the case of failed, and PA fails alone. Okay. So for that, just here, it is main thing is that just we have to denote events first. Okay, because here just we will use what? Conditional probability, because has failed. So first of all, just we have to find the probabilities for events. Just denote. This is question what? 15. So here let EA and EB event that subsystem A fails, even that subsystem B fails. Okay, B fails. Then PEA fails. It is given that here in the questions, what question? PA fails, point 2. Subsystem A fails, point 2. It is given. It is given. Similarly, P, what gives? PB fails alone, and also P A and B fails both. Both fails. That is P EA, and that means intersection. Okay, we can write intersection here. P intersection B. A and B both fails. This A fails, B fails, both fails. Intersection. So this is given what? Also here 0.5. So 0, 1.15. Okay. And also here it is given that P B fails alone. Also P B fails alone means what? P B fails alone means P B EB minus P A intersection EB. When both fails, that situation is subtracted from P B fails. That is called P B fails alone. Okay. So what P B fails alone means P EB minus P EA intersection EB. So here P B fails alone is given. Here main thing is that P B fails alone. This P EB B fails minus both fails situation is subtracted. So it is given what? Given 0.15. 0.15 is equals to PEB minus both fail situation 0.15. So from here we can see that PEB, this is equals to this plus this means 0.30. Okay, 0.30. Just now, first what we have to find? P A fails, B has failed. Now we have P A fails oblique B has failed means what? Conditional probability. Just we can write P EA by P B. This is equals to what? P EA intersection EB upon P EB. This is conditional probability. This intersection is by PEB. So this is equals to 0.15. This is equals to, just we get 0.30. So this is equals to 0.15 upon 0.30. So this is equals to what? 0.5. Just 0.130. This is 1 by 2. 0.5. Okay, 0.5. So this is our first answer. And second. Your second is what? We have to find PA fails alone. PA fails alone. How can you find it? Just like this formula. P A fails alone means P A fails minus P A enters, both fails per portion. Okay, so this is equals to what? P A fails given 0.2 minus P both 0.15. 15. So what? 0.05. Okay, so this is 0.05. So this is second answer. Just conditional probability is used here, and this formula is main. Very, very important. Okay. So this is the solution of question 15. Now question 16 here. Question 16. See here what? Bag A contain 3 red, 4 black balls. Bag 2 contains 4 red, 5 black balls. On ball is transferred from one bag to bag 1 to bag 2. Bag 1 to bag 2. Then a ball is drawn from bag 2. First procedure is what? Just one bag is transferred from first bag to second bag. And then one ball is selected from second bag. The ball so drawn is found to be red in color. Just drawing ball is red. It is given. Just for finding probability, it will be on the second event. Okay, already happened. And find the probability that the transferred ball is black. This reverse probability. Just we will use what? Base theorem here. We will use here base theorem. Very simple. You need to be events ball transferred from 1 to 2, and just we can write what? We have to bag. There may be two types of event at the time of transferring the ball. Okay. We can transfer red ball also, we can transfer black ball also, because there are two bags. Okay. So just see here. First bag 1 and bag 2. Okay, here what given? Just 3, 4, 5, 4, 5. 3, 4, 4, 5. So 3 red, 4 black, 4 red, 5 black, ball. Okay, we have two bags. Just first bag containing this ball, number of balls. Clear? Just first position, just one of the ball is from this bag transferred to second bag, from first bag to second bag. There may be two situations, red ball may be transferred, black ball may be transferred. So these two events just denoted by U1 and E2. So U1 and E2 respectively denote the events that red ball is transferred. Here let 16, let E1, E2, what? Events, just write event that. Event that red ball is transferred from first bag to second bag. First bag to second bag. Red ball is transferred. First event. We may transfer red ball, transfer black ball. Suppose red ball transferring E1 event. and same black ball. Black ball is transferred from first bag to second. Okay, these are two events. Then PE1 means what? Red ball is transferred from first to second. That is selecting red ball. I am just putting here. So selecting red ball 3 by 7. Okay, so 3 by 7. And similarly E2. What? 4 by 7. Black ball is drawing. 4 by 7. The total is 7. So 3 by 7, 4 by 7. Selecting red ball and black ball. Transferring to the second event. Now, what is the probability we have to find? Here, single ball is drawn from which? Single ball is drawn from second bag after transferring. Okay, so here, select the ball, single ball drawn is red. So we have to find, suppose, also let A event, also let A be the event that drawing ball is red. Okay, event that the drawn ball is red. Then clear? Drawn ball is red from the back 2. So here we can find the probability that then probability of A by E1. Okay, when a red ball is transferred to this, red ball is transferred, E1 says red ball is transferred. A be the event that the drawn ball from second bag is red. From second bag is red. This is actually because ball is drawn, a ball is drawn from back second. Na? So this event that the drawn ball from second bag is red. So red ball from when this event already happened, that is red ball is transferred to here and selecting one ball from here. So red ball is transferred to here, there is a 5 red. So 5 by 5 plus 5, 10. 5 by 10. 5 by 10 equals to 1 by 2. Very clear? Similarly, and P A by E2. It is also clear that red ball from second bag, when black ball is transferred to there. So black ball is transferred to there means here 6 ball will be black. So 6 plus 4, 10, but red is 4. So 4 by 10. So 4 by 10, that is 2 by 5. Clear? 2 by 5. Now, we have to find the probability that when this ball is red, selected ball is red, and provided it is given that the transferred ball is black, that is E2 by A. E2 by A. So, by Bayes theorem, the probability that drawn ball is probability that the transferred ball is black, probability that the transferred ball is black. It is given that drawn ball is red is given by drawn ball is red, second event. So P E2 by A. Transferred ball is black, E2 by A, by Bayes theorem. So what says Bayes theorem? Here, just this is equals to P E2 by A is equals to P E2 into P A by E2 upon P E1, total probability here, A by E1 plus E2 P A by E2. Clear? Just solve it. Put the value. P2 4 by 7. So just 4 by 7 upon 4 by 7 right here. 4 by 7 into P2 4 by 7 PA by E2 2 by 5. So 2 by 5 upon just 3 by 7 PE1 3 by 7 into plus 4 by 7 into 2 by 5 here 1 by 2 PA by 1 by 2. Just solve it. We can see here 7 7 7 cancel out. So 15 by 2 and just solve it, you can get 16 by 31. 16 by 31. Okay, 16 by 31. So this is the answer of question 16. 16 by 31. So record probability is this. Just first of all, suppose events and find the record basic probabilities and then use Bayes theorem. Then you can get previous reverse probability. Okay. So now 17, 18, 19, there are questions for as objective questions. So very simple questions are there. So just do practice of this type of questions as objective questions. Here given what? AB are two events such that PA is not equals to 0. Not equals to 0 means in the formula just that probability will occur in denominator. So that's why there is given that PA equals to not 0. Okay. And also PB by A equals to 1 is given. So then just we have to find which option will be correct here. So here it is given that what? AB two events and PA equals to not 0, 17 given not 0 and also what given? PB by one. Just which option will be correct? Just here. Okay. Here option is given at A subset B, B subset A, and B phi and A phi. Which of the correct? So here given this. Here just we see that PB by A is equals to 1. we know the formula PB by A. What P? B intersection A upon PA is equals to 1. So here we see that P B by A can be written as also PA intersection B, PA. Just we know that A intersection B equals to A, then probability can be written like this. That is here, what? A intersection B is just like A, then A subset B. A option is correct. Option A is correct. Okay, in the question, option A. So A is correct answer is what? A. Now question 18. That is also an objective type questions. Just you can discuss it. What will be the solution of this? Okay. So just use conditional probability formula here. Here question 18. PA by B is greater than PA, then which of the following is correct? Just here, if PA by B is greater than PA, 18th question. If PA by B is greater than PA, it is given, then which of the correct? Just option first, option second, option third, option fourth. First option is what? PB by A is less than PB. PB by A is less than PB. And second option is what? P A intersection B. A intersection B is less than PA into PB. And third option is PB by A is greater than PB. And PB by A equals to PB. These are the four options are given. Just we have to decide which of this is correct. It is given. Just what we can do? Use this formula, because here B by A intersection B, here A by B. Then P A by B is greater than PA. Just use formula. Okay, use formula. Its formula is what? PA intersection B upon PB is greater than PA. Conditional probability. Conditional probability. Formula. Okay. So just we can see that here. P A intersection B is greater than PA into PB. Here PA intersection B is less than PA PB. B is not correct here. Okay. So here we see that what? This is not correct. Okay. And for testing other thing, what we can say? Just see here. This is not correct. Okay. Clear? P A intersection B is that is B is not correct. Now, from here we can get also for testing of that options. Just P A intersection B upon PA we can write. Here just take PA here, then greater than PB. Just here, just see conditional probability. Here PA, that means PB intersection A. PB intersection A upon PA. PB. Because A intersection B and B intersection A, same. So, this. By using conditional probability. PB by A is greater than PB. So, PB by A is greater than PB. The third, this is correct. Third option is correct. Okay. So, this is not correct. Third option is correct. And PB by A equals to PB is not correct. So, third is correct answer. Okay. So, just you can use formula and then decide which of the option is correct. Okay. So, question 19, there is one other questions for objective questions. Okay. So, just see, A and B are any two events such that PA plus PB minus PA intersection A and B equals to PA. Then which option is correct? Here, what are the options? Just given what? An option is what? Just see. Okay. Question 19. Here, if A and B are any events such that PA plus PB given, what given? PA plus PA plus PB minus PA and B means PA intersection B is equals to PA. A and PA will be cancelled, but option is what? What are the option? A, what is A? PB by A equals to 1. B, PA by B equals to 1. C, PB by A equals to 0. And D, PA by B equals to 0. Which is correct? Which of the option is correct? Just we have to see. Here given this, that PA will be cancelled. Very simple. What? B, PA cancel. So PB minus A and B means A intersection B equals to 0. Just we can write it like this. Okay. Now we have to test for this. PB by A by B, B by A by B means conditional probability. Just set up it for conditional probability. Okay. So here see that PB equals to, just transfer it on the right hand side, A intersection B. Then we can write P A intersection B is equals to PB, just reverse writing. Here PA intersection B upon PB is equals to 1. What is this? PA by A intersection B by PB means PA by B. PA by B equals to 1. PA by B. B is correct. Option B is correct. Okay. So PA by B equals to 1. This is not correct. This is not. B is correct answer. So these are the solutions. Was the solution of some questions from miscellaneous exercise. So today's miscellaneous exercise is completed except the questions from binomial distribution, okay, and mean variance. Just do all the questions in your copy and also solve all the examples of this exercise because probability chapter is very, very important, and send me some of the solution of out of these questions, okay, for your attendance.